Okay, we have already a good number of attendance, so let's see. So first of all, welcome, good afternoon. Welcome to this LightMe open call event. LightMe is a European project, and my name is Pedro Catanino. I work at EWF. EWF is a partner in this LightMe project. And today we are organizing this event to talk a little bit the project, the LightMe, and of course the open call that we are organizing also that targets to attract SMEs around Europe. And the area of the LightMe project in this open call is lightweight metal alloys. So this is the focus of the project and this open call. So regarding the event that we are having now, this is the agenda. So we will start to have a presentation regarding the open innovation testbed concept. Then we will explain a little bit the pilot lines of the project, also what kind of services we can offer. We will have a short coffee break, more or less in the middle of the session. And in the second part, we will focus on the test cases and finally explain what is open call, how to submit some proposal, and so on. Just to emphasize that you are welcome to make questions at the end of each presentation, each topic that we have here. You are welcome to ask something that you want to clarify, and also to remind that event is recorded. So I hope you agree with that. If not, please inform us about that. So I wish you a good event today. Uh, and now we go to the presentation of the open testbed concept. That is that will represent my colleagues from Polyme. Luca or Chris, I don't know who will present from you.
Pedro, thank you. I will present. So
Okay.
I need probably the authorization to share. Okay. You should see now the screen, correct?
Yes.
Okay. So good afternoon, everyone, and welcome to this event. My name is Luca Magagnin. I'm the coordinator of the LightMe project. So let me thank all of you for attending this meeting. And also I want to thank all the partners of the LightMe project for the work done up to here and for the preparation of the open call. And so specifically, I want to thank Pedro, Alex, and Chris, and all the others who contributed a lot to the preparation of this open call. Probably an open call at this stage will not mean a lot to you, but will be very clear at the end of this event. In this short presentation, I just want to highlight to you the concept of the OITB, which means Open Innovation Testbed, and some more details about the LightMe project. Just an introduction, because during the other presentation you will see what you can get from the LightMe ecosystem as a company, as a research institute. The concept of the Open Innovation Testbed is very important in the last few years. So the European Union is intensively promoting this kind of action. And so if you see the last funding scheme, they are based basically on this kind of structure. So what does it mean, open innovation test bed? But first of all, the idea is the open innovation, which is a fundamental point nowadays. So the possibility to give to everyone, means every company, every single person who wants to be in contact with an ecosystem dedicated to a specific topic should be in some way granted by the setting up of this test bed. Test bed means the possibility to network and to, let's say, combine university, research institutes, and companies with great part of research, of activities dedicated to research, join together in order to, let's say, promote the technology or the materials involved in the specific action of the OITB. As you see in the picture, in the bottom part of the slide, the idea is to have, let me, okay, you should see, okay, just a second. Now you should see the pointer. So the idea is to put together in a sort of, let me say, cross-fertilization approach, many actors. Of course, each actor will bring together to the other its expertise in a specific part of that topic, and so together they will form this ecosystem. The structure that is provided is that a client, which can be a company, European company, will see not many actors, but also only, let's say, what is defined as SEP, or single entry point. So the single entry point is another important part of these test bed actions. So the single entry point will favor the interaction between companies, small companies, micro companies, large companies, with all the actors of the ecosystem. And so the idea is that this should facilitate the access of clients, even in the case that they have never been in touch with resource structures, for instance, or services providers. So to facilitate the engagement of this company with the ecosystem in order to get services, to be in contact with new technologies, and the idea is to also receive services with added values with respect to those services that can be received by only one of the actors. That is the idea of the open innovation, so to favor the access to this structure, and test bed, so with the possibility to be to see and to receive the services from many entities. There are recently, of course, open innovation test bed dedicated to different topics. Of course, today, considering also the aim of the LightMe project, we refer to lightweight materials and the combination of these lightweight materials with nanomaterials. And so, of course, if you introduce the idea of nanomaterials, the application can be in a very wide, very wide range. Of course, the possibility to have a synergic actions among the partners, among the actors of the ecosystem, will favor the generation of let's say, new technologies, new knowledge about nanomaterials, and the combination of these with the light elements. We will see, I will provide you more details about the specific aim of the LightMe project in next few slides. The impact of all these action is to promote the dissemination of the technology, the dissemination of the knowledge, favoring, for instance, or to improve the everyday life of citizens, providing new materials, saving energy, because we all know the possibility, and we all know that if we have the possibility to reduce the weight of, for instance, electric vehicles, this can save energy, can reduce the impact into the environment, and so generating at the end let's say an ecosystem with an improved and high expertise in the specific field of that ecosystem. So why? Basically, we have already discussed some of this point. We say the major or the most important point from the EU, from the European Union point of view, is of course to facilitate small medium enterprise at the European level to receive services at a high level in order to promote their capability to stay in the market, to be competitive, to be more competitive, and to possibly enter new markets. So the overall idea behind the OITBs is to favor the European market, to improve the capability of the European community. In this case, we can say both from the market point of view, from the financial point of view, but from the knowledge point of view, and so from the research point of view, to be competitive with the rest of the world. As I said, there are examples, many examples of ITB. For instance, LightMe belong to specifically to a group of 4 OITB projects dedicated to lightweight materials. Some of them are dedicated to, for instance, polymers, plastic materials. In our case, we are dedicated to metallic lightweight alloys. So we talk about aluminum, titanium, and magnesium alloys. I just want to go to the last point. Of course, an important aspect of the ecosystem is to favor also the dissemination and the communication of the technology, or of all the actions taken by the partners and by the single entry point, and so by the ecosystem, and to cooperate, of course, with the other testbed ecosystems. And so this is also the reason today of this open call, because within the project we have the possibility to, at least in the first part of the ecosystem, to provide, to select actually at the beginning some projects, and this will be clarified later, and to sustain and to promote and to demonstrate the usefulness and the advantages coming from the ecosystem, approaching these selected test cases. Specifically about the LightMe project, you see here the LightMe project consists of 25 partners. We are basically at the end of the second year. It will last for 48. 15 countries are involved. The budget allocated is of course important, and you see here the participant, the partners of the project, and the Politecnico, in this case Politecnico di Milano, is the coordinator. As I said, the LightMe project is specifically dedicated to lightweight metal alloys. So we talk about aluminum alloys, magnesium alloys, and titanium alloys. With not only to this material as say alloys, but the other important part of the project is the implementation of the some of the existing pilot lines at the European level to a higher TRL, in order to be able to produce not only, let me say traditional alloys, but alloys, the same alloys in composite, with the composite characteristic. So with the possibility to produce nano composites. So just to be more clear, the possibility to have the dispersion into all these alloys of nanoparticles of different nature, specifically tailored for the application in that specific alloy, with the scope of generating lightweight materials, lightweight components with improved properties. And in this case, improved properties means not only from the mechanical point of view, as anyone can expect from composite material, but also with new functionalities of the same component with respect to, let's say, the same component without the composite characteristic. And one of the example is, for instance, the possibility to disperse into some of the alloys titanium oxide nanoparticles for the, let's say, biocompatibility. As you see here, I will come back on this concept. So let's say the keywords are pilot lines for lightweight materials, and specifically metal matrix nanocomposites of lightweight materials. The LightMe being an open innovation test bed, of course, shares the same aims with respect to the other ecosystem. So to favor the access to users across Europe, access to pilot lines, specifically access to new materials, composite, access to new technology, and access also to new knowledge. Of course, the ecosystem, as you will see also later in the next slide, is not only related to materials, to pilot lines, but let's say the major characteristic of this ecosystem is that the single user can let's say receive services also in terms of business plan, IP protection, and so the synergy of the different actors of the ecosystem is also fundamental to provide, let's say, a full, let's say, contribution to the single user. The reason of lightweight materials, I think, is, or the selection of lightweight materials is very clear to all of us, and especially in the world where the electric vehicles is a sector extremely growing. Of course, the reduction of weight means the reduction of energy needed to move the same vehicle, but the same example can be done for ships, aircraft, spacecraft, and so on. So the idea is to, with the possibility to produce nanocomposite of aluminum alloys, of magnesium alloys, of titanium alloys, the possibility to implement the performances of the materials, and this will have an effect also in the design, and so in the engineering of the component, of the final component. As I said, the services are, let's say, extremely can be included in a wide range, and later you will see presentations for each of all these aspects. As I said, one of the most important keywords is the upscaling of the pilot lines, and so you see here that we, in the LightMe, specifically in the LightMe project, we have 3 casting lines, 2 lines for the additive manufacturing, and so having a look also to new technology, and 1 dedicated to powder metallurgy. Not only pilot lines and production of materials, we have partners dedicated to the, let's say, production and the tailoring of the nano aggregates that we want to introduce into the specific alloy. We have partners which are expert in the monitoring, so process control and process monitoring, in the testing of the composite material, of the mechanical properties, of the morphological and structural behavior of these materials. Very important in any project is, of course, the possibility to have a support from the modeling point of view. This is extremely important in saving time in the designing, in selecting much better the final component, the final characteristic of the component. Innovation management, so not only, let's say, focus on materials, but just the idea is to provide, let's say, a full service, so business plan, marketing, technology transfer, and again, fundamental, because one of the idea of the open innovation is the transfer of knowledge, fundamental is the training, so the training activities. We deal with new materials, we deal with nanomaterials specifically, so very important aspects are regulation, standardization, health and safety. So we have partners extremely expert and let's say in the nano safety sector and in dealing and providing protocols in order to use nanomaterials, introduce nanomaterials into the company, into the small medium enterprises. Very last slide. I don't want to take too much time. So again, just a picture of the pilot lines. We have 6 pilot lines. So low pressure die casting, high pressure die casting, green sand casting, and then the 2 additive manufacturing, metal wire. You see here, and the other one with the powder process, and the sintering extrusion one. You will have details later in the following presentation. So again, LightMe project is an important ecosystem, will be and wants to be an important example of ecosystem dedicated to lightweight materials, especially specifically composite lightweight materials. You will see the following presentation for more details regarding the services we can offer. We are at the setting up of the single entry point. Today, the event is dedicated to the OpenCall, so to the possibility that we want to offer to companies, European companies, to be in contact with the ecosystem, to propose their project, and with the possibility to see this project, let's say, realized within the ecosystem. Thank you for your attention. Of course, I'm available for questions, and thank you again for attending.
Let's see if we have any question on the chat, or I think not, but let's see. Okay, I think not.
Okay, so I think you can move to the following presentation. I will stop the sharing. Just a second.
Okay. Next presentations are about the pilot lines. I think we can start for the low pressure die casting. Or yeah, low pressure die casting from Ogi.
If you can my presentation in there.
Hello, Peter.
Yes, I can hear you.
Yes, okay.
See if we get the right. Yeah, I got the look. So thank you for the kind introduction, Petro and Luca. So I would like to give a quick, a brief overview of what we're doing here at the ÖGI, and then about the pilot lines and how we come from traditional sort of like coffee cup metallurgy to real castings in our pilot lines. So just a quick overview of the Austrian actors and research activities. So in Austria, we use the Austrian Foundry Research Institute. So I'm heading this together with Gerd Schindelbacher. I'm also heading at the Montansiedl Leoben, the chair of casting research. Then we have sort of like a group where it looks after the dissemination of foundry know-how, and that's done by the Progress Austria. And then we also have a foundry and trading association in Metall Technology Austria with 17 different branches, including the foundry industry. And that's basically the actors which we have in our background as well. So the UGE, just to give you an overview, is a joint research institute of the Austrian foundry industry, was established after the war to redevelop Austria after the war. We have currently 45 employees, and our research facilities and competence in the whole field of casting technology is unique in Austria because we also have an own little foundry with us, and we are one of the leading non-university R&D centers in Europe. So we have 30 accredited testing procedures according to the norm you see here, and we have a fully equipped pilot foundry which we use in our LightMe project. And we also have other networks. One is the ASIA Austrian Cooperative Research. It's the second largest non-university research organization in Austria with over 650 employees, which allows us to have access, for example, to granular materials in terms of concrete or casting sand. But also, very important, we're very close to the Montana University, and we have a cooperation between the two casting research institutes, the OGE and the chair of casting research. And you see that here, the teaching more fundamental side is at the chair of casting technology, and the more applied side is at the OGE. And we all have our customers in the focus as we have with our pilot lines. Okay, so let's go to our customer contacts. We used to work with customers, and our focus is the foundry industry, but also the supply industry with foundry equipment manufacturers and suppliers of raw and auxiliary materials. Of course, the use of castings are very heavy focus as well, particularly the automotive and train transportation industry, rail and aerospace, and the general engineering side. So this is exactly what we have in as our sort of like target focus in our pilot lines in our LightMe project as well. And then, of course, we're always active in dissemination of activities. We work very closely together with other R&D facilities and organizations. So just to give you a brief overview of our figures, 2019. So we had a turnover of 4.7 million euros, 242 customers, over 1,000 orders from 6 countries. And you see we have a very large project funding scale there. And also you have to think in Austria, most of our funding is not fully funded, only 50%. So we have another 50% funding from other members or invoice contracts, which are actually part of our research funding. And to give you a brief number of 2020, we survived with a black zero. And so we will be, for 2021 will be another challenge in this financial side, on that financial side. So what's our field of competence? So we have our sort of like field areas are applied research and development, engineering, casting quality, failure analysis, material testing, surface bonding and coating technology, numerical simulation, and the technology transfer. All a bit what we do also in the other pilot lines of expertise. In the other ones we have sort of like supporting know-how here, which we bring into our pilot lines. So here you see our R&D fields and research projects, industry, national, EU funded. I won't go through all of them, but you see the focus on casting processes, metallurgy, molding materials, casting alloys, materials and their properties, simulation, digitalization, and follow-up processes. And we have a very wide range of funding opportunities from the EU right to very local level at our local county here in Steiermark. So to give you a quick overview of our laboratories. So we have our pilot foundry will come into more detail later on. Chemical laboratory, physics laboratory, mechanical test laboratory, mechanical workshops, and computer tomography, as well as metallographic laboratory and test laboratories for molding materials. So really everything you need to deal with customers that are coming from the foundry industry, but mainly these services are only applied to individually for individual customers, so they don't come and do everything at once, although we could do it, but usually customers pick and mix their own, according to their own requirements. So now we come to our equipment, which was used in the pilot line. And so we have two units there. So one is the low pressure die casting machine in red, the LBTC pilot line. And then we have a sand casting facilities, which is for green sand castings in blue, the GSC pilot line. And if I start with the low pressure die casting line first, so we have two different alloys will be cast in there. So we have the aluminum silicon 9 copper 3 alloy, which is a standard alloy, and the AlMG3 alloy. And the furnace we use is electric, and the furnace capacity goes up to 150 kilograms. So that's real castings and not just what I mentioned earlier, laboratories castings, which we do at the university and stuff like teacup charges. So, and then of course the challenge is to maintain nanoparticles of the type silicon carbide and titanium oxide to go into the alloy with different means of from rotary degassing and ultrasonic treatment, and to maintain these particles within the alloy and then within the casting. To give you a quick idea how this low pressure die casting works, it's a bit like a barometric mercury cell, and basically with the pressure you get in the mercury barometric cell. If you increase the pressure tube, basically the mercury rises. And so similar works here. You have just instead of mercury, you have aluminium. And if you increase the pressure in the vessel below, which you see in silver, you have a rising tube. And in this rising tube, you then get your casting, your die, and that fills then the die in a very controlled way if you control the pressure well. On the other side, you see the green casting sand facility. Mainly it's the mixer for the green sand, which gives you near to industrial scale quality, actually it's better even than industrial scale quality. And we use different alloys there. Again, we use the aluminum silicon 9 copper 3 alloys with iron, and the brackets iron means it's can be a recycled alloy. Then we use the aluminium alloy, the magnesium alloy with 9% aluminium and 1% zinc. And again, the aluminium magnesium 3 alloy as well. And there we cast in sand molds. We can produce the sand molds by hand. We'll show you later on how we make them with particular models. And we use electrical induction melting for different type of alloys. And again, we go from 150 to 25 kilograms and use the same nanoparticles we use for the low pressure die casting, and the same melt treatments with rotary degassing and ultrasonic treatment to keep the particles in suspension in the melt. So here you see the molding shop for the sand casting. We have sort of different types of molds available. So you can basically have we all know you can build sand castles at the beach. And this is a bit of a similar task we have to do here, just we don't use just water, but we use sort of like either water and bentonite, which is sort of like, which the dark, sort of the method below. And we use bonded sand, which use polymer bonded sand in the sort of vernishes we see in the picture above. And we mix these sand as a granular material together and then form it on our mold, similar like you do the sand mold with your children on the beach. If you make it very, very simplified, but that's basically how we do it. And you see, of course, we don't use sort of like little star shapes and cake shapes, but we have industrial technological shapes. And you see here a green model and a step plate of aluminium, and each step gives us sort of like a different cooling rate later on to access the effect of cooling rate on our material properties, together with our nanoparticle we want to introduce into our material. And basically you have this green mold, and which is actually in this green mold you actually press your sand mold around it and put a frame on top of it, and you basically fill it with sand and press the sand against the green mold, and then you withdraw the mold and you have the cavity, and then into the cavity you feel your specially treated melt with your nanoparticles. And you see here some of these samples you see here, which we tested first out with sort of like normal alloys without any nanoparticles, but they also did the same thing with nanoparticles. We're actually capable of producing samples sort of like in real sample size scale and not in the coffee cup scale. And the next challenge we will do, since we think we have the technology to upscale it, is to go to the 100 kilogram class, where we then go to like close to industrial series production. So a pilot line, in other words. So you see the other model, the previous one was from aluminium, here you see it from magnesium. Magnesium has slightly different thermal physical properties. You have to adapt the mold a little bit. And again, you see here step plays, you use a slightly different furnace. You have green sand or phenolic resin. And you have to use additional properties into the sand because magnesium tends to react with quartz sand. So you have additives like sulfur and other coatings on it, and you use a cover gas to make your castings on industrial scale. And here you see on the green model, you can see actually the frame, the white line going all around us. That's basically where the metallic frame sits on top of it to give the sand mold a bit of hold. So this is the low pressure die casting machine here. And can I actually, you can see I hope you can see my cursor here.
Yes.
And you basically see this is the low pressure, this is the furnace which you can put under pressure. And in between, in the middle, you have a little tube. And if you put the pressure onto the melt inside the furnace, the melt will rise into the tube, into the mold here. And you can control the pressure very, very accurately, because the flow of the melt will depend on the pressure you apply. And this gives this sort of like Giemann machine here, gives us a very nice control over the pressure and flow rates inside the melt, so we don't produce any defects in the casting. And here you see the type of mold we use, and it's a step mold again to make sure we can see the effect of different cooling rates of our nanoparticles in our melt. And you see here the challenge will be that we want to cast more than one casting of the 3.3 kilogram weight here, which is actually a typical weight of a medium-sized casting in industrial scale as well. And so this is the challenge we want to do next. And basically that concludes my pilot scale for the low pressure die casting and the sand casting facilities. And thank you for your attention.
Yeah, let's see if we have any questions.
Yeah.
And thank you for your presentation, Peter.
You have to push.
I think we don't have any questions.
Okay, I will stop it so you have control again.
Yeah, I think we can go to the other pilot line. High pressure die casting from University of Brunel. Can you
Yeah.
listen? Yeah.
Okay.
Thank you. Do you have?
I'm gonna share the presentation. You can see the presentation now.
Yes.
Good afternoon, everyone. This is Gong Yu speaking. Today, I'm going to talk about the high pressure die cast pipeline in the LightMe project. First, I'm going to introduce a little bit of the Brunel. So, where is the high pressure die casting pipeline? It is within the Brunel University, Diecast, and the university is located in the west of the London. It's about 15 minutes driving, and it's very easily accessible from Europe across the world. And the university was founded in 1916, about 15,000 students from over 100 countries, and different schools here from engineering, science, and to arts. And also we have different research themes. So the high pressure die cast is basically located in the Diecast center. Diecast is a Brunel Center for Advanced Certification Technology. Was established in October 2002, and the research group comprised over 100 members of staff and students. And we are working closely with industry partners like Constellium and Jaguar Land Rover, and also all the valuable industry partners. And the research activities in Diecast is from fundamental research to industrial applications focused on the solidification and lightweight methods. We are from the atomic modeling to casting to the final products component. So in terms of the high-pressure die-cast pipeline and workflows, we can see basically the whole workflow is we start from ingots and melted, and then afterwards we degas the melts and try to follow by introducing nanoparticles into the melt. And also after that, we cast it into the high pressure die caster, and afterwards we check the microstructure and the mechanical properties of the castings from the castings. And during the whole process, we basically have some facilities that are available. For example, for the composition test, we got a foundry master. For high hydrogen content, we can use the RPT test. We use the degas mixing unit to introduce the nanoparticles into the melt. And we also used different types of the monitoring instruments like IR camera to check the die or the melt temperatures, do some analysis of thermal analysis. And we have got GOM facilities to check the geometry, do some other measurements of the castings. And also, of course, we have CT and also other instruments to check the defects or the agglomerations in the castings. So on top of that, we have also other wide range of research facilities there available, which could be contribute to the high pressure die-cast lines. We got different types of casting lines, and also we can do mechanical testings. Now we can do different types of characterizations, X-ray diffraction, CT scanning. We have different types of SEM and TEM facilities there for us to check the microstructure of the component or the castings. We also have the hardness indenters, tensor machines, fatigue machines, etc. And for sure that the high pressure die cast machine is the mainly facilities we're going to use in high pressure die cast pipelines. So specifically in terms of the two high pressure die cast pipelines, we basically have two machines they are available. One of them is the FRAC 450, which is a smaller one. It can deal with volume of aluminum casting from 1.5 to 5 kilograms, and for magnesium, it can produce 1 to 3 kg in terms of volume. And the machine was equipped with two 40 kg furnaces, and the melt is being transformed to the short sleeve manually, and the cycle time is about 120 seconds. And vacuum system here ranging from 50 to 70 bar. The maximum size of the platen there for this small machine is about 1060 times 1060 millimeters. In the right hand side, you can see we got different vacuum channels. One is connected to the short sleeve, another one is connected to the vacuum, connected to the die cavity. So another larger high pressure die caster here gives you some information that details about. First is the volume is for aluminium from 8 to 32 kg, and I've got 600 kg dosing furnaces, and the machine has been supported by ABB robotic systems, and the typical cycle time is about 60 to 120 seconds as well. and the machine is also vacuum assisted, and we can the vacuum can reach to as low as 20 to 30 mbar, and the maximum size of the platen here is about 2 meter times 2 meter in terms of the platen size. And yes, this is basically the two pipeline, especially for the caster. In terms, of course, in relation to the two specific pipelines, for now we are working closely with other partners. As the previous presenters has mentioned, we got different sections like monitoring, testing, or modeling will be can insert into our pipeline to give us support for the LightMe project as a whole. So yeah, that's basically everything. Briefly introduction of the two high-pressure die-cast line in our side. If you have any questions, thank you very much.
Thank you, Wang. Let's see if you have any questions regarding your pilot line. Probably not.
Yeah, I'm gonna stop the sharing.
If not, we can
leave
move
it to you.
Yeah, we can move to the next pilot line.
Thanks.
The next is about the metal wire additive manufacturing pilot line is from Ayman. I think Pilar is here.
Yes, hello. Hi, Pedro. Hi, all.
Hello.
So I'm going to share my screen.
Okay. Here he is.
Okay.
Okay.
So it's full screen. Hopefully you can see well.
Yes.
So hello, everyone. Thank you for attending to this webinar. So I'm going to present the metal wire additive manufacturing pilot line. That is a technology based in direct energy deposition using laser as a focus beam and wire. And this pilot line is in charge of Ayman. So very briefly, Ayman was established or was born in 1967. So many years promoting R&D projects and technology services to the industry in that fields. I'm going to, okay. So we are more or less 250 people, and we work in more or less more than 50 R&D projects per year. We are here in Spain, on the northwest of Spain, in Porriño. We have two buildings, and we are very close to Vigo, that is the main city of Galicia. In R&D areas, we work in materials and smart systems and smart manufacturing, laser-based manufacturing, micro and high precision manufacturing, and environmental technology. And usually we work in projects together. So we are try to be more or less very transversal. This is our participation in projects in the Horizon 2020. And this pilot line is in charge of the advanced manufacturing department that is very focused in laser manufacturing. So one of the most active field of research nowadays is additive manufacturing. So here you can see some components that can be that have been manufactured by Ayman in different projects and in different materials using always the process, but using powder or wire, because we have both capabilities here in our facilities. So let's move specifically to our role in LightMe. So in LightMe, we are in charge of this pilot line. So there are two additive manufacturing pilot lines. So our pilot line is in focusing laser and in wire. And also we participate in other of the building blocks of the ecosystem as testing or monitoring. So our upgrades in LightMe, because we have several cells working with this type of process, but the interest of LightMe was the inclusion of a new coaxial wire head, build plate with a controlled temperature, a system to work under inert gas atmosphere, above all because LightMe is very focused on lightweight alloys that are very reactive under air. So it's very important to protect these alloys in order to achieve the better properties. Also, we have capabilities on the online monitoring of, for example, the melt pool. And we work also in optimizing the process parameters when we deal with these new materials, above all in the case of metal matrix composite. And also we collaborate with other, let's say, building blocks in terms of, for example, the offline inspection of the quality of our parts and simulation tools. So three main elements have been included in our new pilot line. One is this head that works with a coaxial wire. The other is a table that allows us to work into axis, summing up to the axis in which a robot can work. And also put all together, we need to protect this working, let's say, place with an inner chamber in order to remove all the oxygen to work properly. So the advantage of these upgrades can be summarized here, because, for example, in the case of working with a laser coaxial head instead of feeding the wire laterally, is that the melt pool is independent of the welding process. So we can achieve better properties because we are not dependent of the direction or the gravity. Also the thermal impact, so the dilution is lower, and so the distortion become also lower. So the quality and the repeatability will be better. In order, for example, to avoid some problems or defects in additive manufacturing as the crack susceptibility, we can reduce the residual stresses that can, let's say, develop these cracks, preheating the table or the base plate in order to minimize this problem that is very typical in additive manufacturing because of the fast cooling of the process. And this table has been designed to allow all the movements inside the working zone. Together with this, we implement this new inner chamber that allows us to work in under 50 ppm of oxygen that is suitable for working with very reactive metals as titanium, magnesium, and aluminum. And also we are adapting a system that we already developed for powder LMD, that is coaxial, that is a thermal camera, an infrared camera that is going to be placed at first of axis in order to monitoring the melt pool. And in that sense, it allows us to, for example, reconstruct the thermal history of a component in a 3D way. So this is our cell with the robot and the rotating table. with the laser coaxial head that is putting inside this, it's like a, let's say, a glove box. So we have gloves here to manipulate on the working space. We have to open this bag, but in any case, we have include some zippers in order to manipulate the head or this thumb, trying to minimize the losing of the inert atmosphere. So our services include this, let's say, parametrization when we deal with these new materials, but also the manufacturing of test cases. Our performance in terms of wires, more or less 2 kilos per hour. That is quite high for additive manufacturing, and more or less to manufacture, in that case, a 0.5 meter component, but in any case, this bag could be adapted to bigger components. So this is at this moment designed for the test cases that we are going to deal inside of LightMe project with the current partners. And also service as process monitoring and for sure that characterization of the materials developed in terms of quality, optimization of the process, and then the final properties. So, for example, in this slide, you can see an example why to protect these materials is important. For example, here you can see titanium. Titanium is very reactive, and these colors are completely forbidden in welding and in additive manufacturing, because these colors are related with the oxide layer coating that appears when we have a higher content of oxygen in the atmosphere. So as we increase the gas protection, we can improve the quality, the surface quality, and in that case, with this silver gray color, is completely acceptable. So bear in mind that, for example, in welding, this color could be acceptable because at the end you can remove it, but not in additive manufacturing, that all the components are manufactured layer by layer. So if you allow this minimum oxidation, but you put other layer on the top of this previous one, you are going to have a lot of layers with a very fine layer of oxides on the middle, and is going to have a strong impact of the mechanical properties of your coupons. So it's very important to have a high protection of our working place, like here. So also some capabilities that we have on our own, but also in collaboration with other partners, are, for example, monitoring capabilities. In that sense, this process is very digital, and it's very important to have a lot of data from the process in order to control all the steps. So while we manufacture a coupon or a part, we can monitor, for example, the temperature with thermocouples, with the typical oscilloscope, and also with this kind of equipment, this lab jack that can work with a lot of thermocouples. And also we can use thermocameras in order to have a look to the process for the heating and cooling of the component. And also we have this kind of infrared cameras that that can be used for monitor the melt pool. And in that sense, together with the thermocameras and the thermocouples, using this kind of data file that is the HDF5, we can reconstruct a component in terms of the thermal history, and we can check what happened with this part during the manufacturing. So then this kind of information can be related with the simulation and also with the properties or defects that you can have in your test case. And also it's very important to test the material, the coupons, the components. So in that case, in IMAIN, we have some testing capabilities and also some partners that can support us with other techniques, our analysis. We can, let's say, make a quality control and inspection and a characterization with applied to the feedstock analysis, because it's very important to check the quality of, for example, the powder. In that case, we are going to use wire, but it's very important to have a look how this feedstock is. And when or once we have the deposits, we can carry out some microstructural analysis in order to see how is the height or the width of our melt pool. One is cooled, and also when we apply different layers, we can check the quality of the microstructure. And in terms of testing, we can do some mechanical tests as tensile, and also with the support of ISQ, we can use miniaturized specimens in order, for example, to screen different parts of a coupon that can have different properties in terms of different temperature, or because of the residual stresses, because at the end, the additive manufacturing process is very anisotropic, and it's very important to check the properties in the different directions of our manufactured part. So in that sense, we can carry out destructive testing, but also apply non-destructive testing, inspection, like in this case, to check if the coupon has pores or cracking or other type of defects that can impact on our properties. So that's all from my side. Thank you very much for your attention, and for sure, if you have any questions, I will be very happy to answer it.
Thank you, Pilar.
You're welcome.
At the moment, we don't have any comment on the chat, any requests for questions. Okay, I think we can go for the next pilot line. That is the Borealis from Yiddish.
Hello, good morning.
Hello, Gianluigi.
Can you hear me? I'm
Yep.
going to share my screen.
It's showing now.
Can you see my screen? Can you see my presentation?
Yes, we are seeing your screen.
Okay. Okay, I'm John from Iris SRL.
Sorry, Gianluigi. Just a comment. Can you switch the presentation, because we are seeing the presenter mode, so we are seeing the screen from the presenter and not the full screen.
I'm waiting.
See if you can change. If not, we can see, but.
Is it better now?
It's the same, but I think you can go ahead.
Can you see the screen with the presentation mode now?
We are seeing the presenter mode, but you can present. We can see the slides.
Okay. As I told you before, I'm Gianluigi De Simone from Iris. We are the owner of the Borealis pilot line. And now I'll give you a few words about who we are. We are a small enterprise specialized in developing application of laser and plasma technologies, and we are located in Turin, in the north of Italy. We work in the 4 different files. The first one is plasma for environment, so we develop some technologies for soil and waste treatment. The second activity, the second file is about the additive manufacturing. So we are involved in the so of course in this project, but also in several projects about additive manufacturing of metal. And also we work with laser processing design, so we are able to develop some smart technologies or some smart self-adaptive solution for cutting and of course welding process. And we are able to also to a sort of know-how transfer, because we can engineer some process and sell the process to the customer. Boreas pilot line is composed by 2 machines. The first one on the left is an anthropomorphic robot. The second one on the right is a Cartesian movement. They are equipped with with a 5 kilowatt fiber laser, and we have a redundant deposition head, and I will explain in the next slides. Both have 6 degrees of freedom and 2 other degrees of freedom on the rotative table. The Boreas pilot line can work with different materials such as steel, titanium alloy or aluminum alloy, and in the project also with the titanium with titanium carbide. We have a very huge volume, and so it's possible to manufacture larger component or many small components. And the flexibility of the process is of course for the dimension and the shape of the final component, but also for the flexibility in the material approach. One of the activities that in the LightMe project is the possibility of upgrade the pilot line. So we are going to we want to maintain a stable process, avoiding any heat accumulation, and we want to avoid the presence of defects such as of course pore, but also some cracks. So we want to in the context of the project, we want to develop a project control, and we want to optimize the project equipment. Just a few words about the monitoring and control system. It takes place through the acquisition of the melt pool image. So the geometry, or better, the dimension of and the temperature of the melt pool are compared with the expected values from the mathematical model. And if there are significant deviation, feedback is given to the robot, which corrects the process parameter and reestablishes the optimal working condition. The second activity of upgrade is, of course, about the project equipment. We are going to perform this task because we want to obtain some specimens and of course some final component with an excellent quality. The deposition head which is used in Boreas pilot line is made by 4 interchangeable nozzles with the possibility of tuning the focus of the powder with the focus of the laser. and we are able to make a different alloy in the melted pool, because in each nozzle we can through different material, different metal. In the first stage, we use a coaxial gas shielding cover, but we discovered that it was not enough, and also we are going to we are going to re-engineering the most stressed components of the deposition head, because we of course need an easy and quick setup. As I told you before, we discovered that shielding gas was not enough for avoiding the installation of titanium carbide. So we designed and built our inner gas chamber. So here I want to show how it works after the first improvement of the pilot line. In the right side of the slide, there are some best tests we performed, and there are few pores, no cracks, and no oxidation. Okay, thanks for your attention, and I hope I was clear. And if you have some question, please ask me.
Thank you, Gianluigi. See if there is any question. I think not. So we can go to the last pilot line to be present today. So this is the spark plasma sintering combined with cobalt extrusion from Nope.
Yes.
Darius, hello.
Everyone, can you see my screen in the presentation mode?
Yeah.
Right. This is the last presentation in this part of today's OpenCall event. And at the beginning, I would like to say a few words about our institute, which belongs to the Łukasiewicz Research Network in Poland, the third biggest research network in Europe, localized in 12 cities, consists of 32 research institutes. We are located at Poznań in Poland, and we are a partner of the LightMe project. In our institute, located is SPS Cobalt Pilot Line. It means this consists of spark plasma sintering device and also cobalt extrusion press. At the beginning, I would like to say a few words about spark plasma sintering, which is one of the most advanced sintering technique under a pressure, which is many times lower than in conventional compaction sintering technology route. And in this technique, we can obtain full dense material in a very short time. It means it depends on the material, but it is more or less half an hour. The maximum temperature is higher than 2000, and it is related to the specific feature of SPS process. We can sinter materials with melting point higher than 3000 degrees. It means that this is a wide applications area of various materials. In this machine, which is also the biggest one in Poland, the maximum compacting force is 250 kilonewtons. There is also available very fast heating up to 400 degrees Celsius per minute. In this device, it is possible to obtain sintered disc with diameter up to 80 millimeters and thickness of 20 millimeters. All the sintering processes can be runs using various atmospheres. It means hydrogen, nitrogen, argon, or in vacuum. This process is controlled by two pyrometers from 250 to 2500 Celsius degrees. This is top and radial pyrometer. And obtained materials using SPS HPD25 device manufactured by FCT system from Germany is the main model of our pilot line. In general, in the world, all researchers used tools for the SPS technology made from graphite. In our case, in LightMe project, we optimized this technology for using tools from W360 hard-working steel, which allow us to obtain better accuracy of dimensions at temperatures up to 600 degrees. It means that it is for aluminum-based composites, and also for higher temperatures, it is possible to use one of the more advanced grade of graphite, high strength 2334 from Emerson. Also, in the LightMe project, we designed and manufacture assembly module to assembling these tools in a self-automatic process. And also we are in our lab is available disassembly module for disassembling this set of tools after sintering process. And the obtained sintered compacts in a very fast track. In LightMe project, we are responsible for sintering all of aluminum 7075 alloys reinforced by nanosilicon carbide in a very fast track. It means it is more or less 20 minutes from the powder material to full dense sintered body. And this sintered body is extruded in two types of presses. First one, smaller, is available at Poznań facility, and the bigger one is available at Gliwice facility in our research network. And in this specific feature, there is a cold extrusion of sintered sample with high oscillation angle with some oscillation frequency. And for example, in JVST test case, the sintered disc with diameter of 60 millimeters are extruded in one process to 8 millimeter. It means that the extrusion rate is 55. And what is related to this, during the extrusion from the sintered disc to the extruded rod, we have a significantly decrease of grain size, which is correlated, of course, with increase of mechanical properties of the obtained profiles. In this EBSD maps, you can see a significant decrease of the grain size, and what we can offer in the LightMe for JVST partners and for other one that will be interested in this technology is the association of two advanced sinteric techniques. It means this is SPS and COBA extrusion, but in this case for manufacturing of fasteners, forging is needed to make a head, for example, and additional heat treatment to increase the strength and decrease the ductility after the processing rod. And of course, at the end, we are offer the characterization from microstructure observations to mechanical properties testing. So that's all from my side. Thank you for your attention, and if you have questions, please ask me.
Thank you, Darius. This was the last presentation from the pilot lines. I don't know if there is any question regarding any presentation that we had now. And if not, we can go to the next topic, that is about the LightMe services.
Yeah, I will be presenting the technical services of the ecosystem.
Okay.
So, let me share my screen. You see my screen, right?
Yes.
Okay. So, good evening from my side. I'm Xavier Costula and I'm working at Politecnico di Milano. And I will present you the technical services that go beyond the pilot lines that we have already seen. And these are services included in the monitoring, modeling, and testing building block. So a short presentation for the partners of the monitoring building block. We have STAM SRL, which is an Italian engineering SME with great experience in mechatronics and industrial automation. We have ISQ, which is a Portuguese company providing inspection, testing, training, and technical consultancy. And we have Iristec, which is a Spanish engineering company specialized in real-time monitoring and intelligent digital platforms for industry. So the services that the monitoring building block is offering are monitoring and control system, as well as quality control system for additive manufacturing processes, a monitoring system with thermographic cameras for high pressure die casting process and spark plasma sintering process, a test bench for the assessment of small, medium-sized gearboxes equipped with dynamic torque emitters and sensors for vibration, and finally, quality control and testing for metallic and composite components. Now, the modeling building block, we have Access, which is an independent research center in Germany with great experience in simulation of material process and properties on different scales. We have the University of Brunel and ENOP that they presented themselves during the previous presentations. We have again STAM and IMEN that has already presented itself. So the services offered by the modeling building block are a combination of modeling tools on different length scales to support pilot lines. They provide access to a wide variety of modeling and simulation tools that will allow faster optimization of the process. And of course, they support process development, including nanoparticle distribution, for low and high pressure die casting, for metal wire additive manufacturing, and for spark plasma sintering process with modeling. They also provide services on simulation of mechanical properties of nanoparticle reinforced parts and studies of the influence of nanoparticle distribution, meaning surface agglomeration, agglomeration during solidification, and process parameters and conditions. So the last building block with technical services is the testing building block. Here we have Politecnico di Milano, and we are an Italian scientific technological university, and we're offering microstructural and physicochemical analysis within this building block. We have OGI from Austria, IMEN, University of Brunel, ENOP, and ISQ. So within this building block, the services offered go from microstructural characterization with SEM-10 X-ray diffraction to physicochemical analysis, mechanical properties testing, such as tensile testing, wear and abrasion testing, thermophysical properties testing, and finally, non-destructive radiographic testing. So that's it from my side briefly.
Okay, regarding the non-technical services, it will be Alex.
Yes.
Yes.
Just let me, yeah. Sorry, because
I don't see also questions, so.
Okay, so sorry. Okay, now. Sorry for this. Okay.
No problem.
Yeah.
Yes.
Yeah.
You can see the presentation or the presentation mode?
Yes, it is okay, Alex. You can go.
Okay, perfect. So, non-technical services, we have, as the target of the Open Innovation Testbed is to provide holistic solutions, or what we call one-stop shop solutions to the SMEs or to the enterprises that will enter the ecosystem in order to receive the services. The ecosystem will provide a series, a group of non-technical services that target on the holistic characterization and provision of data necessary for bringing a new product, a new material to the market. So the groups are environmental assessment of environmental impact through LCLCC, health and safety, regulation, consultancy, innovation management, access to funding, and training. The core partners involved in this group of services are the University of Burgos in Spain, ISQ in Portugal, EWF from Belgium, Axia Innovation, our company from Germany, Incotec from Spain, and also we have a law office for a specific group of services related to IPs that is from Belgium also. So I will go quickly because I see that we only have 10 minutes. So we have environmental impact. What we can do is conduct life cycle assessment through a specific use of software in compliance with ISO, the existing ISO for the LCA. And also we can conduct LCC analysis, financial analysis and project valorization to estimate costs like CapEx, OpEx, other costs, and also to include possible incomes at the various steps or the various phases of the value chain. Interpretation and integration of these results using multi-criteria optimization models to understand the optimum solutions and to apply decision support tools leading to optimal decision making regarding raw materials, regarding functionalities, etc. In the health and safety, this part is led by ISQ. The previous part was led by University of Burgos. So in health and safety and nano safety, we have the leader ISQ, and also Politecnico di Milano provides assistance together with University of Burgos, especially in the part of the nano safety. We have identification and compliance with regulatory context related to issues about health, safety, and environment, with focus on the pilot lines. So we are focusing a lot on the occupational health, about possible application of this in production line, and perform also nanoparticles monitoring activities in order to identify release of nanoparticles in the working environment that range between 10 and 420 nanometers. These services will be provided through a two-stage approach. One is related to completion of a questionnaire provided by ASQ, and also in situ monitoring measurements, again by ISQ in the production line of the partners. Regulation and standardization, this is provided by EWF, the Belgium Association of Welding and Joining. We have consultancy on standardization and regulatory aspects that will be tailored to upscaling concepts related to lightweight metal matrix and nanocomposites. Also depending, of course, on the market that the partner needs to address, either it's automotive, aerospace, or the other markets that the LightMe Open Innovation Testbed serves. Just to mention, because I'm going a bit fast, all the presentations will be available after the event, and also that the event will be available for someone to follow it on our website of LightMe and on YouTube. Innovation management services, here we have Axia Innovation and Incotec. We provide a holistic solution on innovation management, starting from identification of key exploitable results, conceptual planning phase, IPR management, and development phase. The target here is that the partner that will enter the ecosystem will be able to develop their own business plan, a valid business plan that will cover all the aspects, internal and external environment, capacities, team, and of course the financial analysis as we said before. In this part also we will have a separate part that I will speak later concerning the IPs. Here for the IPs, together as I said with the Timelex, the law office from Belgium, the LightMe IPR strategy is based on 4 main pillars. The LightMe main target is to enable the IPs for the partners. By default, LightMe support partners in developing and exploiting their IPs, and LightMe does not require a transfer of license of IP to LightMe itself or the LightMe partners. Here, I need to say that the next period, a new entity will be established. This will be a non-profit organization that actually it will be the single entry point. This will represent the LightMe ecosystem, and it will be a new organization where a new client, a new customer and partner can go there and collaborate with the NPO in order to facilitate him to bring a contract together with the partners that belongs to the LightMe project. So instead of a partner, a client, speaking with 16 different partners, we will have one entity that is the LightMe NPO, where the client will go there and will make the agreement on behalf of the whole ecosystem. This will facilitate, of course, the partners will speed up the process of agreements, etc. So this NPO the role will be to act as a single entry point for the specialized services of LightMe, and also can act as an IPR negotiator or intermediator and organizing individual assignments. IPR implication implementation in practice will be regulated by 2 agreements. One agreement will be the agreement between the NPO and the core partners. In this agreement, the NPO will have also the mandate to provide agreements with the clients on behalf of the core partners. And the second agreement that concerns more our end users will be the agreement between the NPO and the end user, where everything related to IPs, etc., will be mentioned there. As I said, LightMe will provide these templates for assignments. I would like to highlight also this part on the IP. Prior to conducting a research that will have some cost, we need to be sure that we are free to operate, but nobody else has done what we want to do. So the LightMe consortium will also provide the service of patent sales and freedom to operate through a detailed analysis of existing patents and insights on the patents in order to see trends on these technologies, the main players, etc. Access to funding. This service will be led by Incotec, the Spanish partner that also assists on the part of the innovation management. Here the case is that the customers, the partners that want to enter the ecosystem, will be given the opportunities inside our open innovation environment to demonstrate and showcase their concepts, so they can attract funding from external entities, that investors that want to invest in such technologies. Of course, the ecosystem, the OITB, will provide all the assistance to these partners in order to develop their pitches, to develop their showcases, and come in contact with these investors. Also, we will have technology transfer, assessment, and exploitation. And as I said, again, innovation funding that will not be restricted only to external investors, but we will also be able to provide services related to public funding, national or European funding, for example, in the framework of the Horizon Europe that is about to start. I will go with it. Training activities, the group of training activities that again is led by EWF in collaboration with all the other core partners, will provide workshops and seminars on different aspects. So we are targeting the audience that is interested in this field of lightweight metal alloys and composites, and also that is interested in these new technologies that will be applied in the framework of the LightMe pilot lines, for example, monitoring of these lines, use and monitoring of nanoparticles, new type of composite materials, etc. And in parallel, non-technical seminars that will be related, for example, with REACH regulation, mentoring innovation, etc. In the framework of the project, that means for the next 24 months, we will arrange 3 open to the public training activities that are new technologies on metal matrix composites added from manufacturing overview, management and IPR in an open innovation ecosystem, operational procedures, and eco-efficiency. So thank you. As I said, you will be able to receive the presentation and also to watch again this workshop in YouTube. Pedro.
Yeah, thank you, Alex. See if there is any question. If not, we can make a short break. I think there is no questions. So short break of 10 minutes and we can rejoin at 4 o'clock. Okay. So
okay,
see you in 10 minutes. So can I start? Are you there?
Yes, Pedro, maybe we can start.
Yeah. Okay, so hello again. I take a coffee now, so I think we're ready for the second part of this event. Just to finalize all the information regarding the LightMe, I will talk a little bit about the test cases, and then we will go to the major point today, that is the OpenCall. So just to finalize this part regarding the test cases. So the test cases, we can see that are some practical applications. And we have some goals here, some objectives to complete. So we want to validate the proper operation of our ecosystem. So we want to ensure, evaluate, and validate if the pilot lines, if also the services, all these ecosystem and all these relations between these areas of LightMe, if they are working properly. And if not, we want to review and to proceed with the specific improvements that we need. So we will receive some feedback regarding these test cases, and then we will evaluate them and to see in which areas we can improve, and to have a better ecosystem with better services, better pilot lines, and so on. So regarding what kind of test cases we have in LightMe to ensure and to evaluate if the ecosystem is working properly. So we have mainly 8 test cases. They are split in in two different test cases. We have two test cases that are more on the upstream level. For example, they are regarding the raw materials providers. And here we have two partners, MBN, Nanomaterialia, and Magnesium.com. So they provide some kind of raw materials. And here, what kind of test cases we have with these two partners. So the first one from MBN, it is regarding aluminum and titanium pre-alloy nanostructure, metal matrix nanocomposites in form of a powder. So, and this powder, this kind of material, will be for the pilot line regarding the spark sintering plasma and also the additive manufacturing with a TRL technology research level, level 5. The goal here is to set up efficient production cycle for this kind of powders, and the aluminum will go to application regarding the sintering, and the titanium goes to the additive manufacturing. So the second test case regarding this upstream level is also regarding aluminum, but in this case regarding also with magnesium. And here these alloys will go to the application of the metal wire additive manufacturing pilot line from Iman, with the goal to decrease or increase the lightning of the alloys. We have more or less a number in our mind, so 30 to 35% lighter than in the other way. And for example, the approach to reach this goal will be, for example, using electromagnetic melt shearing. So these are two test cases regarding the upstream level. Regarding the downstream, so the end users, we have a test case from AMEL, that is evaluation of precision machinability of titanium. They are using some parts, ribs and aerofoils, and also some panel cells from planes. And here the big goal is to reduce the weight of these parts, because it goes to airplanes and other kind of vehicles, and also to enhance the resistance of these parts. So they will use some alloys with metal matrix nanocomposites, and they will use also the metal wire manufacturing pilot line. The second test case that we have here is from our partner GVST. Here it's a titanium alloy for lubricant and wear resistant slip bearings. And here our goal is, of course, to increase the strength and stiffness of these bearings, and they will use the pilot line for the sintering from ENOP, and they will use an aluminum alloy to reach these goals. Finally, the two test cases that we have, the first one here is from Group Campacus, using aluminum alloy, and here the focus is to use this alloy to produce handles and doorknobs with self-cleaning and or antibacterial properties, using the green sand casting pilot line. And here it's a very nowadays news, so it's very reachable to use this nowadays regarding this kind of pandemic. Of course, objective here is to have antibacterial properties. So they will use 2 pilot lines, and let's see if we can reach soon these results that we want. And finally, the last test case by Hydria. They want to produce pinions produced by the high pressure die casting pilot line, and they want to decrease the component weight in more or less 60%. And mainly these are the 8 test cases that we have to ensure and to test our pilot lines, our ecosystem, if it works properly, and if not, we have time to make the necessary changes in order to have everything in order to work properly. So more 2 test cases from Coconus that is to produce a drag brace in order to improve the fatigue resistance and lightweight multifunctionality. Here they will use the pilot line from Ayman, that is about the metal wire additive manufacturing. And finally, the ad group, the test cases, that is a powertrain gearbox produced in additive manufacturing, and here the increase of stiffness and strength with the particularity to have this in all the temperature range, because it will work on higher demand temperatures. And here the alloy will be used by titanium in the process direct energy deposition, of course with metal matrix nanocomposites. We have here in the audience some partners from this that I just explained. I don't know if they want to add something to clarify anything that they want at the moment, and in the future we will share, of course, these results of these test cases and share what we are doing at the moment. So this is the end. If you have any questions, please, you are welcome. And if not, we can go to the last topic of our event, that is now the major topic regarding our OpenCall. Just to remind, this OpenCall is available since the beginning of January, so more or less at 1 month. And now we will explain a little bit more details about this. And if you have any question, you are welcome to ask, and please give us some feedback. So I think will be Alex.
Pedro.
No? Yes?
Yes, thank you, Pedro.
Okay.
So the purpose of the open call and of the entire Open Innovation Test Bed is to promote technologies concerning lightweight metal materials, since they are of crucial importance for applications in many industries like automotive, aerospace, manufacturing, rail, and other niche applications. So the aim is to attract SMEs and other stakeholders in Europe or in associated countries that they have their operation or they have concept in lightweight metal alloys and or lightweight metal alloys composites, and specifically nanocomposites. And they want to develop this concept in an upscale phase. So what we will offer is that the participants that will be selected through the open call to enter the Open Innovation Testbed, they will enjoy free of charge access to the service of the ecosystem. they will have the opportunity to innovate and develop their business idea through the one-stop shop, as I described it before in the single entry point. Receive mentoring and support from industry experts for the concept in various fields, and be part of a wide network that will be established, already started through long-term relations collaboration with key industrial players. So, very quickly, the available services are, first of all, and most important, access to at least one of the 6 upgraded pilot lines as I have presented before. And also selection from a group of services, technical services, non-technical services, in order to assist and to provide finally a holistic solution for the upscaling process. Eligibility criteria. The following types, the types that can be partners, can be applicants for the open call are, first of all, SMEs, based on the guidelines of the EC about the size of the SME, large enterprises, and research and development organizations, institutes, or universities. Also, if we have a small consortium of 2 or 3 partners that have worked together, they can apply also as a small consortium for the open call. This is also eligible. The entities, of course, should be established in the EU member state or in a third country. They should operating in the field of advanced lightweight metal alloys and should be interested in the concept of open innovation. The UK partners are eligible for this open call, of course. There should be no conflict of interest which might affect the objectivity of the proposal's evaluation. That doesn't mean that the partners that will apply are not having collaborations with the core partners of the ecosystem, of course. The legal entities that will apply are not under liquidation or are not under difficulty according to the Commission regulation. The project that they will propose through the open call should be based on original works and should, going forward, any foreseen developments free from third-party rights. Okay, we will pay a lot of attention in the IPR. How the applications will take place. Later we will have also a short, after this presentation, Akis from RDC will have a short presentation on the details of this. The application will be in 2 steps. The first step concerns the application form where the applicant should provide some data regarding administrative issues, the basic aspect of the concept, and the selection of the services that they want to test. I need to say that we have in the LightMe Open Innovation Testbed, we have established 6 building blocks that are the pilot lines, monitoring and process control of the services, testing and environment, modeling, market uptake, and innovation management. In order for an application to be eligible, the applicant should select at least 1 service from each one of the building blocks. Okay. After filling this part, so these are some of the services that you will see inside the platform. Akis will say more things about this part. And then the applicant should prepare a small proposal up to 10 pages, not more, that will have the normal structure of a proposal like we know. So we have the first part of excellence, that is the industrial link and challenges to be overcome. Of course, the objective, background of the concept and technological insights, and the role of the LightMe Open Innovation Testbed ecosystem. That means why the applicant needs the services of the LightMe ecosystem in order to upscale the project, the project that brings, and also which are the services. In the implementation part, we will need a technical work plan that are, let's say, somehow the work packages and how the technical part will be implemented, a description of the expertise and resources to be utilized. I need for you to pay attention on this part, since specifically the part of the resources is very important. I will say also this later, the access to the ecosystem for the applicants will be free, but there is no funding for them. Okay, the advantage that they take and the benefit that they will have is that they will enjoy for free the services of the Open Innovation Test Bed. In the proposal, the applicant should explain the cost of the resources and which of these resources, especially when it comes to raw materials, will be covered by them and which resources should be covered or it is expected to be covered by the partners of the Open Innovation Test Bed. In the project, because whatever we do now here is in the framework of the LightMe European project, the core partners already have in their budget the available funding in order to work with some additional cases that will come through the open call. Of course, this budget is not unlimited. So in the proposal, we will need a good description of the resources that will be necessary for the implementation of the project, and if the applicant can cover or can provide some of these resources, for example, raw materials, etc. And finally, in this part, we will need short risk management, providing the main risk for the implementation, either technical risk or non-technical risk, for example, market-based risks. Finally, the third part is the impact. So we need to, from the applicant, to show us in a clear way what are the key exploitable results from this project, what the applicant expect to receive. It will be a new product, a new material, a new service, a new process. Okay, it should be explained here. What is the market position of this key exploitable result? So we need the unique selling point of this new product or material, etc., and the market that the applicant will address through this new product. And if there are some other expected impacts, for example, social impacts, environmental impact, technological, etc., we will have also a short paragraph on this part. The evaluation process is depicted in the schematic that you see. The open call has been launched on 7th of January, but will remain open for 2 cutoffs. So the first cutoff will be on the end of March, and the second cutoff will be on 31st of August. That means that we will receive application continuously, but at 31st of March, we will select the first application. We will go through the evaluation process. So is it eligible? Yes. We will go through a technical evaluation, an innovation evaluation. We will have an internal evaluation panel that consists of members of the LightMe project. And based on this evaluation and this ranking, we will ask from the applicants to enter the Open Innovation Test Bed at 1st of June or 1st of November. Applications that have been submitted in the first cutoff and maybe have been rejected, they can apply again after this first cutoff for the second cutoff. Evaluation criteria are the technical advantage, the relevance to the call objectives. So, for example, we need to see proposals and cases that are related to the pilot lines that we have, of course, that are related to lightweight metal alloys and lightweight metal alloys composites, etc. Feasibility of the project to project to progress in the TRL scale from 4.5 to 6.7. That means that the proposed project should be already at TRL 4 to 5. Okay, and this should be depicted in the proposal. As I said, feasibility to be carried out in the LightMe ecosystem, feasibility regarding research and development and innovation, business viability, expertise and resources, what I said before. What we are offering? We are offering access to the selected pilot lines and upscaling of the products, support with technical services such as modeling, testing, and characterization, consultancy and mentoring in non-technical services, networking in the framework of the Open Innovation Testbed, and success story promotion for the winners of the OpenCall. What we don't offer is funding from the project. The EC has decided that this specific project in the Open Innovation Testbed group, that are in total around 2022 proposed projects, will not provide what we call cascading funding to the applicants. So the applicants will have for free the services, but they will not get any funding. Cost and origin of raw materials should be analyzed, as I said before, in the proposal, and it should be explained which cost will be covered by the applicants for the raw materials and what is expected by the test bed to be covered. Here we made an assessment based on the experience that we have until now on the operation of the test bed, of the pilot lines, the service, etc. And we can say that the cost of an average, the range of the cost for the test case is between 80 and 150,000 euros. So the gain of the applicant is exactly that they will receive services of this cost for free. For the intellectual property rights and confidentiality, there is a small paragraph that you can read in the OpenCall application. We have it also here. All parties, including both the LightMe partners and the OpenCall applicants, will identify their background knowledge assets that will bring to the project and will provide access rights for the cooperative implementation of the project. Ownership of project results, including joint results generated by two or more partners, will belong to the parties having generated them. And of course, before the applicants enter the Open Innovation Testbed, as we said in the previous presentation, they will sign an NDA and a specific agreement with the LightMe NPO with a single entry point that will cover all the aspects of confidentiality and all the aspects of background and foreground knowledge. Important dates are for now 31st of March that we have the first cutoff. The second cutoff, as I said, is on the end of summer, and 30 of April we will have the evaluation and selection of the 4 new test cases. 1st of June, we intend that 4 new test cases will enter the ecosystem. Similarly, the other 4 additional test cases will enter the consortium, the ecosystem, at 1st of November. The target is to have 8 new test cases, but the final number is based, of course, on the application, on the need for resources, etc. So, thank you. I will stop sharing and I will ask again if there is any question on this.
I don't see nothing, Alex. I think.
Okay, for the, of course, as we said, the whole presentations here will be available.
Yep.
We will also post them on YouTube, etc. The applicant that wants to proceed with an application can, there is a help desk on the application platform that they can it can apply their questions, their doubts, etc., to receive answers. And whoever wants any type of support can, of course, ask. We have a question from Carlos. Yes. Carlos, please unmute your microphone and you can ask directly.
Okay, well, first of all, thanks for the presentation. And I work for the ECCS, and I'm in fact the project manager of another open innovation testbed. In this case, is NewSkin. And well, within our network, we have interest of some of the developments, but a question that I would like to have is what kind of services are expected, what kind of applicants are you expecting? Because, for example, it's just a quick idea, but for us, it will be very interesting if we are able to get really fatigue resistant fasteners or bolts, for example, for some connections that we may have in the steel industry. And there will be also many interest from the from other companies or members of one association that we have in our consortium, that they will be very interested in lighter, more durable components. How do we really apply for this kind of services? I mean that our request would be, for example, that we want bolts to be used in ring flats connections for any kind of application on the steel industry. And in this case, we would be willing to receive like prototypes of bolts to be used in and to test in our applications. How could we apply for this? I mean, is there any guideline or any support? Because it's not so easy to identify what is the guideline that we are looking, the pilot line that we are looking for. It's not so easy to understand the budget, well, of the quantity, expected quantity for the services. Is there any open support or any recommendation, just in the case that we decide to, for example, request like a batch of 12 bolts that we want to try on bolted connections for the steel industry? Or we want to ask for a prototype of a bearing or a gearbox or a gear that we can implement in our companies.
Okay, I will try to answer unless Luca wants to provide an answer. Okay, I can try to answer to this, Carlos.
I'm here, Alex.
Yeah. Yeah. Okay. Do you want to answer or do you want
No, please. I can only say that we have been in touch with Carlos very recently, and so for sure we need to be, let's say, more coordinated with them. So the two projects, the two OITBs, and also with others, can have say very useful synergies and exchange of let's say technologies, not only among the two projects but also among the partners of the two projects. The way how the two OITBs, if that was the question by Carlos, the way how the two OITBs could interact, probably something that we have to discuss separately with respect to a company or a partner of another project approaching and submitting a request for a specific open call. I don't know, Alex, if you agree.
Yes, yes, I agree for the project as a whole. Now, specifically, if there is an interest for one of the companies that participate in the NewSkin project, and they would like to receive some of the services here, from my understanding is that actually there is no background knowledge at this stage. I mean, a company that have developed something and they want to upscale, but for sure they are in the position to provide accurate specifications and requirements on the type of the bolts or what they need, etc. So they can structure, in terms, at least for the open call, they can structure a proposal, okay, that will be based on some knowledge from previous research or from papers, etc. And they can describe their needs based on the specifications, on the properties they want to have, for sure, on the case of materials that they would like to need, to use. I guess that if we're discussing about this part, usually this is about machining. So we need to see which of the pilot lines can be initially utilized in order to produce some basic materials, and then through machining to go to the last to the desired product. So under these terms, yes, they can apply. Of course, it's also what Luca said, that we can discuss at a higher level between the projects on potential collaboration and synergies outside of this open call. I don't know, Carlos, if we have answered your question.
Yes, well, it's for the part of the collaboration, yes, and it's well, I think that I can make some questions, but it was also focused about, what you are expecting is someone really having developed a material that needs to be upscaled, or it's also open for final application. So suppose that not a company from, or an external company.
No, Carlos, we will not restrict it to this, to that the company has already done a preliminary research work and now they can upscale. The open innovation ecosystems are here in order to provide solutions. So if the solution of the problem lays in the expertise of LightMe Open Innovation Testbed, again, there should be a proposal. That's why I said that in the proposal, they can describe the desired product that they want in terms of specification, in terms of requirements, of course, to describe the final product that, for example, the balls will be integrated, etc. Okay, and they can apply on this way the open calls that they are asking for a solution for this problem. It's also something that the test beds can work with.
Okay, so it could be possible to reproduce this element in a new composite alloy just for we to test?
I think that this is feasible, yes.
Okay.
Yeah, so
especially if the alloys are on the alloys that we are working on.
Yeah, Carlos. So I think you just to make a practical example, you are saying that I want an alloy with a kind of dispersed particles, which is not the standard one. If this is possible or not. Of course, what Alex is going to suggest is, of course, you have to do the application, and then, of course, there will be an evaluation if the facilities, including the synthesis of new nanoparticles, for instance, that we have in LightMe, can respond to your request or not. If yes, of course, we are all happy. If not, maybe we can discuss together and find an alternative to the solution that you have proposed.
Okay, perfect. Thank you.
Thank you, Carlos. Do we have any other question on the open call or on the terms of the service, etc.?
I think not.
Okay, Pedro.
Okay.
So maybe we can close the meeting.
Yeah, I think yes. Luca, do you want to say something else?
Let's say first of all, I wish to thank all the attendees, the participants, and all the partners of the project. I think that the only thing I would like to say is that the open call is a great possibilities for companies. Okay, so I would like to invite all of us to widespread as much as possible the possibility of this call, and we are here also to help in order to understand if there are issues in the submission, in the preparation of the project. Of course, we are available to provide some support. So the point is that is a great possibility. And so this means that companies should not be, can I say, afraid of submitting an idea. It's not let's say, we are not delivering marks about the submission. So is a cooperation. The idea of the open innovation is exactly this one. So some company has an idea and want to see if this idea is feasible, can be industrialized, meaningful or not. And this is the chances that these are the chances that the OpenCall can respond to. And so please consider the possibility to submit, widespread the call through the media that you have the possibility to go with, and we are here to support all these actions. So thank you again. Thank you, Pedro, for chairing this event and for all the work you have done. And thank you all.
Yeah, following the words from Luca. So thank you everyone that was here today, the partners, of course, Luca, the coordinator, and the support from Alex, from RDC also. So thank you from the LightMe project regarding the attendance that was here to understand a little bit more about the LightMe project and how we're open.
Sorry, Pedro.
Yes.
Sorry, Pedro. I think that we need, if we have 5 more minutes for RDC, just quickly to show the operation of the platform, maybe.
Okay.
Luca?
Yeah, for sure.
Okay.
For sure.
So sorry, Akis, can we please have a short
Sure,
presentation?
sure. Hello, everyone. I'm Akis. Let me share my screen. A second, please. Can you see my screen? Okay.
Yes.
So, in order to make the application submission fairly easy and accessible by anyone, we created the online application submission tool per se, and we implemented it on the Open Innovation, the LightMe Open Innovation Environment platform. In order to access this tool, you can do it either from the LightMe official project website, which is lightme-ecosystem.eu, by pressing the partners area, or by directly through lightme-oie.eu, which is the domain of the LightMe Open Innovation Environment platform, and selecting the OpenCall through the main menu. Here you have 2 options, to register or to log in. In case someone hasn't already registered, you can fairly easily do it with just entering your email and your desired password. Of course, the required reCAPTCHA action and pressing register. As soon as you register, you will receive in your mailbox an automated email with an activation link. By pressing the activation link, your account will be successfully activated and you will be redirected to this page in order to log in. Providing your email and password, you will see the application form submission home page. On this page, you can see some quick guides on how to fill your application form. You can view or even download the detailed guides, the full guidelines, and then you can start the application form submission progress. So by clicking the start, you will be redirected on the main page of the application, the application form submission tool, which is divided in 6 subsections. A, which is entering the legal entity general information. B, enter the official representative of the legal entity. C, the interest in the OITB, Open Innovation Testbed Services, that Alex mentioned before. D, test case and general features. E, it's the upload zone section in order to upload your proposal. And F, the data privacy policy. The first 4 sections, A, B, C, and D, are a simple questionnaire with text boxes where you can enter your text, option lists where you can select, and checkboxes. You're fairly familiar with this kind of application forms. This is the first four sections. The fifth one is the upload section, where you can upload your proposal and any other relative attachments to the form. You can download the draft file to use as a guide to make your proposal. And also from here, download the full guidelines file if you wish to also use it as a guide. After you have successfully filled your application proposal, you can upload it on this section either by dragging and dropping it here or using the browse feature, which is the standard browse feature. So I just have uploaded the draft file. Please note that your proposal application should be formatted as a PDF file. The other attachments to the form can be either photos, PDFs, or if you want to upload multiple files on each of these sections, you can add them on a compressed zip file and upload it the same way we uploaded the PDF. The sixth and last subsection is the data privacy policy, where you should agree in order to proceed. Below the 6 subsections, you can see there are 2 options, the save the progress option and the finalize and submit. You can save the progress of the application submission as many times as you wish, but you can also finalize it and submit it once. For example, if I proceed here with entering some text and then saving the progress, the system tells me that the progress has been successfully saved. If I go to the home page, the page I was previously in, you will see that the start button has turned to continue, and the system tells me the last date and time, the date and time of the last save. So I can now proceed with continue. I can fill all the rest and show you the application finalization and submission. Of course, please note that all the mandatory fields that you need to fill in order to be able to finalize and submit are marked with a red asterisk. After filling all the mandatory fields, which I hope I will get it right this time, give me a second, please. Save the progress one last time. And now finalize and submit. You see that my application has been successfully submitted. Now all the options at the bottom are gone. And when I return on the home page, I will see that the previously start or continue button now turned to submit and it is inactive. And I only have the option to view my application. And now the application is safely stored on the platform's database and accessible for the reviewers to be able to process it. So this is basically it, and I will be happy to answer any questions if you have.
Thank you, Akis. Very clear, the presentation.
Thank you.
I don't see any questions, so I assume that everyone understood. So to finish this event, we are always welcome to receive any request or any question. So you have the contacts on our presentations that we will made available to you. So if you need anything else in the future, please contact us, and we are welcome to answer and to talk with you. Once again, thank you to be here, and see you next time.
The next event for the open call. Okay.
Yes.
Thank you. Bye.
Thank you.
Thank you.
Bye-bye.
Thank you, everyone.
Thank
Bye-bye.
you.
Have a
Bye-bye.
nice.
Bye bye.
Bye. Thank you.
Bye,
Thank
everyone.
you.
Bye-bye.
Bye bye.
Thank you. Bye.